Hello, I hope your assignment on sequences went well. Today we are going to talk about series, which a series is a sum of all of the terms in a sequence. Perhaps we have a sequence of numbers, but we want to know what they add up to. So I have an example for you here. One of the things I've been doing in this Corona time is I've been trying to crochet. This is supposed to be a washcloth. I don't really know why it's a trapezoid, but it is. So maybe I decide to do 7 rows on the first day, and then I decide that I'm going to push myself to do 2 more rows each day. So on the second day, I do 9 rows, and on the third day, I do 11 rows, like that. Well, if I want to know how far I am total, on the second day, I did 9 rows, but I had 7 rows done from the day before. So I'm actually at 16 rows completed. Or if I move on to the third day, well, I've got 16 rows done so far. So now if I do 11 more, I'll have 27. So that would be the idea of adding them up as you go to see how many total. Well, if you don't have to go very high in a sequence, the easiest thing to do is just write them out and add them up. So let's say that we want to find the sum of the first 8 terms in this example from Monday. This sequence should look familiar to you because it's the one we used Monday as our example one. So if I want to find the first 8 terms, well, I've already got 4 of them written out here. So 7, 9, 11, 13, and if you recall, we were adding by 2s, so this would go 15, 17, 19, 21, and a series, you just add them up. It's fine if you want to use a calculator, I don't even care. That comes out to 112. So if you don't have to go to a very high term, just write them out and add them up. So let's say that you actually need to find the sum of the first 30 terms. Well, suddenly writing them out and adding them up doesn't sound like so much fun anymore now, does it? So we have another symbol that I'm going to teach you, and there's a button on Desmos that will do this really well for you, so you'll really like it. The symbol is a Greek symbol. It's called sigma. So this can be called summation notation or sigma notation. You'll see it both ways. And this symbol means add them up. And with the symbol, we're going to tell the end value we're going to start with at the bottom and what we're going to end with at the top. So we're going to add up from 1 to 30. That'll be the first 30 terms of this sequence. And this is based on the explicit rule. Remember, we talked about the explicit rule on Monday, and the explicit rule for this sequence simplified to 2n plus 5. If you recall, we had that on Monday. So what this means, this symbol means you start with a 1, you plug it in, you see what you get. It would be 7. And then you put a 2 in for n. 2 times 2 is 4, add 5 is 9. That's the second term. And then you put a 3 in, and you go from 1 all the way up like a ladder until you get to the 30. So you just keep plugging the numbers in and working it out, and then you add them all up. But the calculator will do this for you in a few keystrokes. I'll show you how to do that separately. But right now I want to see the symbolism. So this is the low end value that you're starting with, and this is where you're going to end. So this is the high end value. And you put the explicit rule in parentheses. The parentheses are going to matter on Desmos, so make sure you put the parentheses in. There is a second sigma notation that would work for this particular sequence, so I'm going to show it to you. If I started at 0 as my n value, if I take the 0 and plug it in here for n, 2 times 0 is 0. If I add 7, I get 7, which is the first term of this sequence. And if I go next, after 0 would come 1, plug a 1 in for n, 2 times 1 is 2, add 7, you would get 9, which is the second term of this sequence. So I could start by plugging a 0 in for my n, but then I would have to stop at 29 to get all of my terms in. I could go from 1 to 30, or I could go from 0 to 29. You'll get the same answer both ways. When we do the calculation on Desmos, I'll show you that both of them work. All right, now we're going to look at example 3 from Monday. This one should look familiar as well. We had a sequence that went 5, 10, 20, 40, and if you recall, it was doubling. This is relevant to our current corona situation. If you think of a city having 5 patients to start with, and they each infect 2 people, then there would be 10 new patients. If they each infect 2 new people, then there would be 20 new patients. But if you think about it, these 5 patients are still probably sick when these 10 start showing symptoms. So you're up to 15 sick people. You would add them up. And then if you have 20 new patients on day 3, well, then now you're up to 35 sick people. And if you have 40 new patients on day 4, well, now you're up to 75 sick people. So that would be an example of why you would want to add up a sequence of numbers. That's what series is. It's the sum of all of the terms in a sequence. So let's say we want to find the sum of the first 8 terms in this sequence. Well, if you don't have to go very high, just write them out and add them up. It's the easiest thing to do. So we have 5, 10, 20, 40. Our sequence is that we're doubling, doubling, doubling. So the next would be 80, and then 160, 1, 2, 3, 4, 5, 6, and then 320, and then 640, and we would need to add these all up. So if you add those all up, your grand total comes out to 1,275. But what if we didn't want to look at just the first 8 terms of the sequence? What if we wanted to look at 30 terms? Ugh, now the write it out and add them up strategy doesn't sound so great, does it? So let me show you how to write it in sigma notation. And again, I'll be showing you how to use Desmos for this in just a minute. So we would want to go from n equals 1 to 30. So what that means is you're going to plug in a 1, then plug in a 2, then plug in a 3, then plug in a 4, then plug in a 5, until you get up to the 30th term. And we put our explicit rule here. Well, our explicit rule from Monday on this was that we take 5 times 2 to the n minus 1 power. The parentheses are going to matter a lot on Desmos, so I'm showing you how to put the parentheses in here. The other way to write this in sigma notation is I could start at 0, but then I'd have to stop at 29. So if I do that, it would be 2 to the n power. So let me show you that it will still give me the right first term. If I plug a 0 in for my n value, what is 2 to the 0 power? Well, anything to the 0 power equals 1. So this becomes 1. 5 times 1 is 5, and that's my first term. If I plug the 1 in here, 1 minus 1 is 0. 2 to the 0 power is 1. 5 times 1 is 5. So both of these give you the right first term. The second one would have to stop at 29, because if I've already used a 0 to get 30 terms, I would have to go up to 29. 1 to 30 or 0 to 29, both of them have 30 terms in them. There are nicely written out versions of these notes on Canvas, so you might want to check those and reference those as you work on your assignment. Your assignment will be on Delta Math again. We won't always be using that, but it had some good work for sequences and series. Next, I'm going to do a screencastify video so you can see how to do a sigma notation or summation notation on Desmos. So remember, Jesus loves you and so do I, so do your math.